Hello, I'm ETarte, math teacher. This is the 14th in a series of videos in which I show you part of tutoring sessions with Nick. In the previous videos, Nick was a 5th grader. He is now beginning the 6th grade. And in his math class at school, he is studying changing fractions to decimals. To begin this tutoring session that I had with him earlier today, he showed me a worksheet of doing that, changing fractions to decimals. It had a bunch of problems. Some of them looked like this. So I looked at the problems on his worksheet, and here's what I said. This is all correct, except there are two places where you should have a line over a number that's after a decimal point. And you and I talked about that. Do you know what I'm talking about when there's a line?
An integer of an integer?
No. Here's the one you and I are supposed to switch places on. Put your left hand.
Oh.
This is the one that we had in an earlier example. A decimal point followed by a single 3 with a line over the 3, and the line over the 3 has a special meaning. Do you remember what that is?
Isn't that a, Oh, doesn't it go on forever?
Yes.
Infinite.
That's right. It means that the 3's go on without ever ending. Now, there is a very simple and well-known fraction which has this value. It's the same number. And if you know what the fraction is, we can demonstrate this. Do you know what the fraction is?
0.3, which is also known as 3/10.
Right. That's just 0.3 with no line over it. But this is more than that because it has infinitely many 3's after it.
So
this is not exactly 3/10.
So would I call that 0.3/10 infinite?
No.
Or...
Let me ask you something. You see what I wrote here?
Mm-hmm.
I can't write them forever, but let's just imagine this much. How many of these, is there some number of these which when added together would bring you very, very close to one whole? Very, very close to this number. Imagine adding another one and adding another one.
2/3, maybe?
Here's my question. Can you add some of these together and get extremely close to the whole number 1? If you add those, will that be extremely close to the whole number 1?
3, 6.
No.
In
each column. Just add in each column.
Oh. 6.
You get a string of 6's, don't you? Is that extremely close to this?
Yes.
Well, not close enough to suit me. Suppose we put another string of 3's on here, and suppose we add all of that in each column.
Mm-hmm.
What will you get? I'm sure you know what 3 plus 3 plus 3 is.
Sure. 63.
What's 3 plus 3 plus 3?
9.
You get 9's all the way across. That's 99 hundredths. That's 999 thousandths. Is that number extremely close to the whole number 1?
Very,
Very, very, very, very, very, very close. And how many of these did it take to get to 1?
4 of those.
No.
Or 3.
3 of them. That means that there's a very good chance that the fraction, 3 of the fraction, bring you to the whole number 1. What fraction, if you have 3 of them, equals 1? What fraction is that? Yes. For this first fraction, Nick wrote 1/3, and then he wrote plus 2/3 plus 3/3.
1/3, 2/3, and 3/3.
That's right. Actually, if we make each one of them 1/3, that does it, doesn't it?
Yes.
Because what is 1/3 plus 1/3 plus 1/3?
1 whole.
Yes. So we improved it to read 1/3 plus 1/3 plus 1/3 equals 1 whole. That means that is what we call evidence. That means it's good evidence that this equals 1/3. Now we're going to see if it's really true. So I'm saying to Nick that what we just did is evidence that 0.3 with a line over it, meaning 0.3 with the 3's repeating indefinitely, equals the fraction 1/3. We went on to prove conclusively that that is the case, and I will document that part of the lesson in the next video. I hope that you enjoyed this segment of the tutoring session that I had today with Nick, and thank you for watching.